Greetings, math aficionados. This is Victoria, and I do have another example for you from this chapter in this week's work. It's about solving a rational function, and so we're going to take it step by step. We're going to find the domain, and basically when we find the domain, what we're really looking for is what is not included. And then we're going to actually go ahead and solve it. All right, well, let's get started. So here's an example that I've set up for us. So I've got this, this particular rational equation. You can see it right here, right? And we're going to actually be go back. We're going to actually be starting by factoring these denominators. We need to find what the least common denominator is, and the best way to do that is to factor each denominator. So let's see what we've got here. Okay, we've got this first factor here is x squared plus x minus 6, and we're going to factor it into our binomials, fill in our x's. We're looking for something that we're going to multiply to get a -6 and add to get a +1. And that means that the positive is going to have to be on the 3 and the negative is going to be on the 2. So there we go. You can FOIL it and check to see that it's right. Our second term here is x squared minus 4, which is the difference of squares. So we know we're going to again have a binomial. Let's fill in our x's. And it's going to be the square root of the x, which is x, and the square root of the 4, which is 2. One's going to be a positive, one's going to be a negative. And then the last one that we have here, oops. The last one that we have here is going to be x squared plus 5x plus 6. Again, we know we're going to have a binomial with a leading variable of x. We're looking for something that when we multiply, we get 6, and we add, we get 5. Well, that's going to be +2 and +3. So let's take a step back. We're going to think like a mathematician. And what is the least common denominator here? Well, we've got to have an x minus 2. We've got to have an x plus 3. We've got to have an x plus 2. And I think that works, right? So let's think about it. We have an x minus 2 here. We've got that. An x plus 3. We've got that. This is an x plus 2 and an x minus 2. I've got those. And then an x plus 2 and an x plus 3. So there is my least common denominator. So now I'm going to take that information and I'm going to think about this. I can never have 0 in my denominator. So if any number that I fill in for x is going to give me 0, I have to exclude it. So if x is 2, I'm in trouble. That's going to be a 0. And if x is -2, I'm in trouble. If x is -3, I'm in trouble. So I'm going to have to make sure that my domain is going to exclude those 3 values. So the domain, this is in set builder notation, x is not equal to 2, -2, or -3 or -2 in set builder notation. Or if I'm going to write it in interval notation, I'm going to write this as this is going to start at -infinity, and it's going to come up, but it's not going to include -3. And then it's going to go, well, it's going to skip over -3 and then go to -2. and then it's going to skip over -2 and go to +2, and it's going to skip over +2 and go to infinity. So that would be my answer if I was showing it in interval notation. So my domain has to exclude those 3 values. So let's go ahead and solve this problem, and we're going to use the fact that we know what we have is our common denominator. So in my first factor, I have the x plus 3. I have the x minus 2. The factor that I'm missing is the x plus 2. And then I'm just going to keep that 4 up there. Minus, this time I've got the x minus 2, the x plus 2, and I'm missing the x minus 3. That's the x plus 3. Let me go back. What did I have for it? X plus 3. So this is a plus 3. And so I'm going to have 1 times x plus 3. And in my last factor, I've got the x plus 2, the x plus 3. I am missing the x minus 2. So I'm going to have 2 times x minus 2. So I've done it. I've taken care of it so that my denominator is the same on both sides. And now if I multiply everything by that denominator, I'm going to be able to rewrite this as 4 times x plus 2 minus x plus 3 equals 2x minus 4. And that's because when I multiply this by my LCD, that is going to cancel. And when I multiply this by my LCD, those are going to cancel. And all I have left is what's in my numerator. Let's clean it up. So I've got 4x plus 8 minus x minus 3. Let's bring it all over to one side. So subtract 2x minus 2x plus 4 equals 0. And we're just going to combine like terms. So here I've got a I've got a 4x, a minus x, and a minus 2x. And that's going to leave me 1x or x. And then I've got a plus 8, a minus 3, and a plus 4. So 8 and 4 is 12. 12 minus 3 is going to be 9. So x is equal to 9. So if I wanted to write it, my solution set is going to be equal to 9. Hopefully this has helped you with these types of problems. Keep practicing, keep trying, and let me know if I can help you with anything. Have a great rest of your week.